Welcome to Neil's Narratives. And on today's episode, the birth of stars and planets. Today we are picking up on the story at about 380,000 years after that big old bang. The scene is set for something incredible to happen. Just it's going to take a lot of time. Think highway roadworks length of time. A couple 100 million years, give or take. But in reality, with the entire time spans of the universe, this happened rather quickly. Let's get into it. The Dark Ages and the First Light. After the birth of atoms, there was an eerie nothingness to the universe. A few 100 million years of it, in fact. Astronomers call this period the Cosmic Dark Ages, proving yet again physicists are not only smarticle particles, but are great band name generators. At this time, no stars or galaxies existed. We can actually visualize this with one simple trick. Close your eyes. Yep, that's what it looked like. Just clouds of invisible hydrogen gas drifting through expanding space-time, clumping very slowly under the pull of gravity. Tiny quantum fluctuations, or variations in energy levels at different points in space, from the Big Bang had seeded ever so slight differences in density, little pockets where matter was slightly more concentrated. Over time, these pockets pulled in more and more matter, and like a snowball rolling down a snowy slope, the matter clumps got bigger and bigger. Eventually, some of those space clouds grew dense enough that the hydrogen at the centers began to collapse. The pressure rose, and with the rising pressure, things heat up. Temperatures soared. And then, something incredible happened. At around 100 to 200 million years after the Big Bang, the first stars ignited. These weren't ordinary stars. These were giant, supermassive, short-lived monsters almost entirely made of hydrogen. Astronomers call these population 3 stars, and we've never seen one directly, but we know they must have existed, because in their fierce, short lives, they did something miraculous. They mimicked the Big Bang and its ability for nuclear fusion, and if you remember, nuclear fusion is how we go from hydrogen to helium, to lithium, and beyond. The beyond being absolutely crucial for our story. So let's explore that process. The Star Forges. Stars are essentially giant cosmic fusion reactors. At their cores, hydrogen atoms smash together under immense pressure and heat, fusing into helium, and in doing so, they release energy. That energy is what makes stars shine. But massive stars can go even further. Once they burn through their hydrogen, they start fusing heavier elements. Helium into carbon, carbon into oxygen, neon, silicon, and all the way up to iron. Iron, however, is the end of the line in this process because the fusing of iron doesn't release energy. With no energy production, the processes of stars begins to falter. The fundamental forces that hold a star together begin to fail. It's the cosmic dead end for our starry friends. When a massive star's core fills with iron, gravity wins. The core collapses. The outer layers fall inward, rebound, and explode outward in an absolutely whopping detonation. We call this a supernova. In these stellar deaths, elements heavier than iron, like gold, uranium, and the calcium that make up your teeth, are born. Let us ponder that for a moment. Every atom of oxygen you breathe, every drop of iron in your blood, every grain of silicon that makes up the beaches of planet Earth, they all came from the death throes of ancient stars. As Carl Sagan once said,
"The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself."
And that is one of my favourite quotes of all time. Thank you, Carl. Galaxies take shape. While all these stellar life cycles were beginning and ending, the universe was getting organised on a larger scale. Galaxies began to form, vast swirling amalgamations of stars, gas, dust, and dark matter. Gravity drew smaller clumps together, merging them into larger structures. This process is still ongoing today. Our Milky Way galaxy is currently absorbing smaller satellite galaxies, slowly encapsulating them. You can think of it the same way that small soap bubbles meld with larger soap bubbles. Right now, the Milky Way and the Andromeda galaxy are on a collision course towards one another. But not to worry, that is not for another 10 billion years, if it happens at all. By then, our sun will be gone anywho, and I wonder if that highway road construction will be finished by then. Inside these galaxies, stars didn't form in isolation. They were born together in stellar nurseries. Huge cold clouds of gas and dust, known as molecular clouds. These stellar nurseries we can see today, and they offer us stunning visage of cosmic landscapes. In these stellar nurseries, a new kind of star began to appear. Smaller, longer-lived, and often surrounded by something crucial to our story. Disks of leftover material. Dust and gas not pulled into the star itself, instead spinning around it like the escapee flour of a spinning pizza dough toss. It's in those disks that planets are born. Building planets from stardust. Let's zoom in now. We're in one of these protoplanetary disks, orbiting a young star, somewhere in a galaxy not too different from ours. The disk is made up of gas and grains of dust. Tiny bits of metal, rock, and ice form from the elements produced by generations of stars before. Those dust grains start bumping into each other. Most of them bounce off, but every now and then they stick. Electrostatic forces, like cosmic static cling, help the tiniest clumps hang together. Bit by bit, the clumps grow. Millimeters become centimeters, then meters, then kilometer-wide rocks form, called planetesimals. Now, gravity starts helping out. The bigger a rock gets, the more it can pull other rocks towards it. This process is called accretion. Essentially, it's growth by the gradual accumulation of additional layers of matter. Some of these growing bodies become planetary embryos or protoplanets, massive enough to begin clearing out their orbits, dragging more and more matter towards them. If they're far enough from the star, they might gather huge envelopes of gas and become gas giants, like Jupiter or Saturn. Closer in, they stay rocky and small, like Earth, Mars, or Venus. This is due to temperature gradients. Closer to the star, the icy gas particles melt, but further out, they're able to clump to form gas giants. This chaotic period is filled with collisions, some constructive, some catastrophic. In our own solar system, Earth's moon was likely formed when a Mars-sized body slammed into the early Earth. The debris from that impact eventually formed into our moon. Without that cataclysmic collision, our planetary makeup between Earth and Moon would not exist. There would be no seasons or rising tides, and who's to say if life would have arisen at all? Thank you, Moon. We salute you. Also, while we are thanking cosmic objects, we should really give a shout out to our gassy friends. If it wasn't for Jupiter and its enormous gravitational pull, we might never have had a chance here on Earth. Jupiter and its counterparts kind of act like guardians of our solar system by pulling potential Earth-hitting asteroids away from us. We salute you, Jupiter. A familiar system emerges. Our own solar system formed about 4.6 billion years ago from a cloud enriched by previous supernovae. Our sun ignited at the centre. Around it, the leftovers began to get together to form what we see today. Mercury, Venus, Earth, Mars, the Rocky Bunch. Then the gas giants, Jupiter, Saturn, Uranus and Neptune, with their moons and rings, the icy bodies beyond Neptune, and the dusty leftovers in the Kuiper Belt. Earth itself took a while to calm down. For hundreds of millions of years, it was bombarded by debris, churned by volcanoes, and left cratered by impacts. Yet somehow, life would eventually emerge here. But that is for a future episode. The important part is this. From the cooling embers of the Big Bang, through gravity's meticulous work, the universe built complexity. First atoms, then stars, then elements, then planets. Thank you so much for listening to episode 2 of Neil's Narratives. And I'll catch you next time. Thank you so much. Please like and subscribe. It helps a lot. Ta. Goodbye.